This is the NEET 2025 question from electric charges and fields, and we are solving this problem in this video. Let's have a look at the problem first. Two identical charge conducting spheres A and B having their centers separated by a certain distance. Charge on each of them is Q and force of repulsion between them is F. Let's take a pause on that and write down what he is mean to say, right? He is saying that there are two charges Q and Q separated by a certain distance. It was further given that radii of A and B are negligible compared to the distance. So need not worry about it. Assume it like a point charges separated by certain distance r. The force between them according to Coulomb's inverse square law is 1 by 4 pi epsilon naught Q1 Q2 by r square. That is what given for you. That's what F in the problem. Now it was further given that a third identical conducting sphere is brought in contact with the sphere A first and then B finally removed from the both. A third identical uncharged sphere, that is very important. Now what is being done is a new sphere is brought into the picture. Who is that new sphere? Who is not having any charge, Q equal to 0. That was first brought into contact with A. Let's talk about this, right? When first brought into contact with A. See, the spheres are identical. So according to the charge uniform distribution, first sphere is having a charge Q, second sphere is having a charge 0. Once they are got into contact, they will get distribute their charge equally because the charges are identical, spheres are identical. It becomes Q by 2 and a Q by 2, whereas this is the first one, this is the third one. So after getting in contact with the first sphere, it got a new charge of Q by 2. Third one has got a charge of Q by 2. Now what happened? First to A and then with B. Now if you go for the second part, when got in touch with B, B is actually having a charge Q like what is being mentioned. But the third one after getting in contact with A is having a charge of Q by 2. So this is the third one. This is the second one. They are now brought into contact. Again charge will be equally distributed. They will get new charges. Sum of these two charges is Q by 2 plus Q, 3Q by 2. That 3Q by 2 is equally distributed. So this becomes 3Q by 4. This becomes 3Q by 4. So after this, the second sphere will have a charge of 3Q by 4. Third will get 3Q by 4, but it was taken away from the problem. We need not worry. So what's the new status of the charges? After getting the third one into contact, the first is now having a charge of Q by 2. The second is having a charge of 3Q by 4. Now, what is the new force between the two charges is the kind of question that we would like to answer. Well, that's easy now. F dash new force is equal to 1 by 4 pi epsilon naught. New first charge, after because it got into contact with the third sphere, became Q by 2. New second charge, 3Q by 4. Distance has not changed, r square. So F dash is, everything else is same other than this 3 by 4 and 2. So 1 by 2 into 3 by 4 into, everything is same, 1 by 4 pi epsilon naught Q and Q by r square, that is nothing but equal to our original F. So 3 by 8 of original force. So new force is 3 by 8 of original force. That's the answer for the problem. So to solve this problem, we shall have a known important concept that when you got a uncharged sphere who is identical in dimensions and nature with the charged sphere, between them there is an equal distribution of the charge. That's the most important lesson that we shall learn after solving this problem. Therefore, you will be able to solve similar kind of problems. That's it. Thank you for watching.